Thank you for joining me today. We're going to take a look at the next lesson, which is day 7. This is on page 29 in your packet. We're going to go through 29 and 30 today together. And then in the next time I see you guys in person, we're going to go through the rest of this. Okay? Uh, or tomorrow, depending on what happens. So, day 7, similarity in right triangle. So this is just a review of questions we've done in the past. So once again, find the distance to a pond from point B to point C. Surveyor drew in a diagram below. Measurements he made are indicated in the diagram. Use the surveyor's information to determine the state and state the distance from point B to point C to the nearest yard. Now, the key thing here is that these two angles are 90-degree angles. So that tells us that these two lines are parallel. So this is a side splitter theorem question. All right. And we need to remember again is that we're creating two similar triangles here. Okay, so when we look at the really big and the really small triangles, we can now create a proportion. So this whole thing right here is 280, 230 plus 85. Okay, so that's going to be 315. All right, we know this is 120. We're trying to find this. So you can see in the small triangle, if we do small to big or big to small, okay, we can create a ratio here of, let's say, 230 over the corresponding side in the big triangle, which is 315. And that's going to be equal to, once again, the big triangle, or small triangle, I should say, which is going to be 120 over the big triangle, which is this side across the pond, which is x. And then we can cross multiply here and solve. All right, so we're going to do 315 times 120, which is 37,800, is equal to 230x, and then divide by 230 to have our answer. And so we're going to get 164. Nearest yards is equal to x. Okay, question B, which is something we're going to start to get into today. We're going to skip the factoring questions for today. Is that we have triangle CHR, so that's the really big triangle, and then we have another kind of small triangle that you can see that's kind of been drawn in here. All right, we know that angle H here and angle RDO, here's H, here's RDO, are equal, that RD is 4, RO is 6, okay, OH is 4, and we want to know the length of CD, which we can call this X. Now, what we really have in this question is we have two similar triangles again, okay? And the reason we know that is because these two triangles, so we're talking about this really big triangle all the way around here, and then that triangle that we've outlined in red, share this angle, and they have these angles in a congruent. So what you kind of want to think about is what happens if I take this red triangle and I kind of bring it out this way, right? Kind of, we can say reflect it and kind of translate it over here, and I get it to look like this one, right? So R is going to be in this corner, D is going to be here, and O would be moved up here. And we know that we have these two angles congruent, so that's how I know I want D here. They share angle R, if you remember, okay? And we know that DR is 4, and OR is 6. So in the really big triangle, this side is x plus 4, and this side is 10. And so now we can go ahead and create a proportion, right? We could do big triangle to small triangle to do this. Okay, so pause it here. See if you can create a proportion to solve. Okay, so hopefully we did x plus 4, big, over small, which remember is not from this triangle, it's this one, over 6 equals the big, which is 10, not in this triangle, but the one that we made over here, over 4. And now we can cross multiply and solve. So 60 equals 4 times x plus 4. 60 equals 4x plus 16. We'll move that 16 over, okay, to get 44 is equal to 4x, and then x is going to equal 11. It does ask for the length of CD, so that's what this is, since we called that x. So CD would be 11. Okay, just a quick review. So the thing I want you guys to kind of focus in on the fact is that we kind of had to redraw this triangle to make it look like and so that it was orientated in the same way this one was. We're going to do that with these our topic for today. So we're going to be finding questions that start with a right triangle and have an altitude drawn to the hypotenuse. This is a key phrase that often shows up in these questions. Okay. And what happens is if I have a right triangle, and I draw in an altitude, by definition, an altitude is kind of the height of the triangle. So it's going to create 90-degree angles down at the base. And so I went from having one right triangle to having 3. Right? The original one, this is our first right triangle. Here's number 2, and here's number 3. And all these triangles are actually going to be similar to one another. Okay, we can see this if we put a 30-degree angle right here. So I know this is 90. If this is 30, I just pick that number. This becomes 60. This is 60. This is 30. This is 90. And then the really big triangle, we have a 30, 60, 92. So you can kind of get the idea that these are all going to have equal angles and therefore similar. So what we're going to want to do is we're going to want to redraw the triangles so they all look the same but they're different sizes. So you notice this triangle on the right here is the smallest. So we're going to bring that here. Okay. We also have the one on the right, which is the medium sized triangle, and then our original triangle is the biggest. And our job is to try to make proportions and solve for missing sides given information about these triangles. So let's take a look at an example here. Our job is to take a look at this picture, and we're going to draw 3 similar triangles. That's how we're going to start every question off. Key thing here, notice once again, is it says the altitude to the hypotenuse. So what I'm going to do underneath is I'm going to draw 3 triangles. I'm going to draw one that is just as big as the original picture, right? That's this one right here. So we have the right angle at Y. We have the short leg. Okay, we like to call this the short leg, right? Remember the right triangles have legs and a hypotenuse. The short leg, the long leg, and the hypotenuse. The second triangle we're going to draw is just like this one, but it's a little bit smaller. We'll draw it right over here to the left. So this is our medium-sized triangle. That triangle is right here. So notice that we have to take this triangle, all right, we have to flip it upside down and then move it over. We kind of have to reflect it and then translate it. So the right angle is actually down at the bottom, just like the original one was. So however the original one looks, we're going to draw 3 just like it, just different sizes. So the 90-degree angle is here, where W is. All right, we can see it travels to the short leg, which goes from W to Y. So this is the short leg. You can see that this is the short leg right here. All right. And then we have our longer leg, which is this side, and the hypotenuse, which is down here. So the long leg is here. That's from W to Z. And our hypotenuse goes from Y to Z this way. Okay. And the last triangle we'll do here in green off to the side. Now the interesting thing to note is that the short leg of one triangle is actually the long leg and the other triangle. This is the long leg, the green triangle, and this is the short leg there. Our right angle is here, and so across from it is the hypotenuse. So this side, this altitude, is the short leg in the medium-sized triangle, but the longer leg, okay, in the smaller triangle. So we're going to draw kind of a mini-me triangle here. All right, we know the right angle is down here where W is. We know the short leg goes from W to X, so that's here, the short leg. The longer leg goes from W to Y, so that's here. And then this side, XY, becomes our hypotenuse. And so all we're going to do for these triangles is we're going to redraw our three different sizes. We're going to label any side lengths that we're given, and then we're going to look at our pictures that we've created and see if we have sides that are in the same and corresponding positions that we can create proportions for. Okay. So let's take a look at number 2. Write a similarity statement. What similarity statement can you write relating the three triangles in the diagram? So before we do question A, we're going to go ahead and redraw our triangles. Now they're going to look just like this, okay? So we like to call this a chopped out right triangle. Chopped out. This is something I learned in college, just kind of stuck with me. Now, if you remember what a chopper is, okay, a chopper is, you ever see the memes, the guys with the big um, handlebar mustaches? They're always yelling at each other. It's American Chopper. They build choppers. So it's a motorcycle, okay, which it has a very, very big stretched out wheel and sometimes has like super high handlebars. You see guys on the highways riding. We're going to draw our triangles with this chopped out motion here. It looks like a chopper. And the reason we're going to do this, you don't have to draw this part, is if I just draw what I think is a right triangle like this, it's kind of tough to tell which is the long and short leg. Or if I draw a right triangle that looks like this, like which one's the long and which one's the short. So if I, instead of doing these, okay, we want to draw one that's an exaggerated, like chopped out version of a triangle. So keep that in mind as we're going along here. So if we look at our triangle, we're going to draw three triangles that look just like our starting one. Here's a big triangle with the right angle in the bottom, just like it is here. Okay, we're going to draw a medium-sized one, so just a little bit smaller than that. And then we're going to draw a mini-me here. All right, and now we can label. So in the original triangle, I had Q, R, and P. All right. Don't do that. That's an error. Hey, come on now. All right, pause for a second. Okay, what I was trying to do was to change the colors here. So, oh, what are we doing? What are we doing? All right, let's try this again. So we'll go blue for this one here. Okay, so this triangle, or medium-sized triangle, is over here on the right. So we have the 90-degree angle, which is at S. The short leg goes from S to P. Okay, the short leg. And the longer leg goes from P or S to R over here. And then their hypotenuse is going on this side. All right, so you don't have to label the S, L, 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 and H, Y, P for yourself, but you're more than welcome to. And then the last triangle we have down here, we'll go ahead and leave this one in, you can choose a different color if you'd like. Let's go lovely teal color there. All right, so that's this triangle on the left. Okay, so once again, the right angle is at S. The short leg actually goes now from S to Q. And then from S to P, is the longer leg, and PQ is our hypotenuse. So we want to write two different proportions using the ratio SR to SP. Okay, SR to SP. So if you look at SR, that's in the middle triangle here, SR to SP. So what I want you to notice is SR, which is right here, okay, is the long leg, all right, and SP is the short leg. So we want to identify those two sides in the other triangles. So the short leg here is OP and then QS. Those are the two short legs in my triangles because they're all on the bottom, the left side here. Okay. The other side we're talking about is the long leg. That would be these two sides. All right. These are the long legs. So in this triangle, we made a ratio as SR over SP, which was the short leg. Oh, I apologize. Not short leg. Long leg over the short leg. So we want to make the same ratios in these other two triangles. So in the really big triangle here, remember the long leg is PR over the short leg, which is OP or PO. And then in our final triangle, we have the long leg, which is SP, over the short leg, which is SQ or QS. And that would be our proportions, okay? Long leg over short leg. That's all we're going to do. So you just got to take your triangle. Notice that it says either we have this drawn or it's going to say altitude to the hypotenuse. We bust out our three triangles, we label them, and then we create a proportion and solve. So let's do an actual question here for number 3. Okay, key thing here, once again, is it starts off by saying the altitude drawn to the hypotenuse. So that's how we know what we're doing. Okay, so I would see my triangle. I'm going to draw 3 of them, just like this. There's one, there's a big triangle. Okay, here's my medium-sized triangle, and here's my small triangle. So starting with the big one, we have C, A, D, with the right angle at the top. These two right angles are both a D. So in the medium-sized triangle, we have D. Okay, the short leg goes from D to C, and the long leg goes from D to B. And in the last triangle over here on the left, okay, we have a right angle at D. DA is the short leg. Fix that A. And then DC is the long leg, and AC is the hypotenuse. So it says, also note that it says here, what is the length of altitude CD? So in my original question, I want to put an X here. We want to call that that's what our variable is, okay? So make sure you're labeling what side you're trying to find with a variable. Now, in the really, really big triangle, the only thing that I know out of side length wise is that this bottom side has a length of 15. That's all I know. I don't know either of these two sides because I don't have measurements for them. All right. In the triangle on the right, which is the medium-sized triangle, I have a short leg of X, so that goes on DC. And I have this side at the bottom, which is the long leg, which is 12. So that's going to go on DB. In the triangle on the right, we can do this one in black here. Okay. All right. We have a short leg, 3, so that goes on AD. And we have the long leg here of X, which is going to go on DC. So when you're looking at these proportions, you can see that I have these two sides, which are in corresponding positions. Okay, so I'm now going to create my proportion and solve. So I have the short leg and the long leg, and the short leg and the long leg. So I'm just going to make a ratio, and I'm going to decide that I'm going to do short leg over long leg. It's up to you, but I chose this method. So the short leg is X, in this triangle. Okay, the long leg is 12. and that's equal to the short leg, which is 3, over x, which is the long leg. And then I'm just going to cross multiply and solve. So x times x is equal to 3 times 12. So we get x squared is equal to 36. Then remember to undo a square. We're going to square root, and I get x is equal to 6. That's my answer. Now, what you also may have might do here is instead of doing like long or short leg to long leg, maybe you'll do something. Maybe you'll do something else. Like I'm just going to label this again so we have these labeled correctly. Okay. Maybe we'll do something instead of going from small triangle to big triangle, right? That's what we've kind of done in the past. Okay. So what if we do that here? What if we go small triangle, 3 over the big triangle, which is x, would equal x over 12. Does this still work? It sure does, because we're still multiplying x times x like we did here, and 3 times 12. We're still going to get 36 equals x squared. And if you did big to small, you'd still get the same thing. So you can choose to do either short leg to long leg, or we can do big triangle to small triangle like we did before, just as long as you're creating your proportion with those corresponding sides. Okay, last question of the day here. The drawing for the right triangular roof truss represented by triangle ABC is shown below. So if you're looking at a house, right? The house, this might be the truss. This is kind of what's holding that house up there. Once again, don't have to draw that. I'm going to get rid of mine here. All right, in the accompanying diagram. If angle ABC is a right angle, so there's our right angle here. And once again, the altitude drawn on the hypotenuse. So you know the other right angles are at D. BD is 4 meters. It says DC is 6 meters longer than AD. So which one of these do I need to know first? Right? I need to know AD. That's going to be X. DC is 6 meters longer. That's going to be X plus 6. Now we're going to go ahead and create our proportions and solve. So before we do that, we need to draw our triangles. Okay, so let's see them. So once again, we're going to draw them just like they look here. So we're going to draw a big triangle with the right angle at the top. We're going to draw a medium-sized triangle. Once again, right angle at the top. And notice we're drawing that chopped out version, that exaggerated stretch to the side there. Okay, so we can see which one's long and short. All right, so in the big triangle, we have A, B, C. That's the really big triangle right here. In the medium-sized triangle, we have D, B, C. So once again, D is the right angle. The short leg is over here to B. And the longer leg goes over here to C. Just going to fix up that B here. All right. And then once again, in the super small triangle, we have a D. We have the short leg on the bottom, goes from D to A. And the longer leg goes from D to B. And now we're going to go ahead and label. So once again, or in our original triangle, the really big one, the only thing we know is that this side has a length of x plus 6, which is 2x plus 6 combined. That's all I got. Okay, and the triangle on the right, I have a short leg of 4 and a long leg of x plus 6. So 4 on the short leg, x plus 6 on the long leg. And then the triangle that's on the left here, we have a short leg of x and a long leg of 4. So once again, I'm looking for sides that are in the same spots. So we have 4 and x, which are on the short legs, right? And then we have x plus 6 and the 4, which are on the long leg. So now we can go ahead and make our proportion. So we can either go triangle to triangle or short leg to long leg in both. So let's go short leg over long leg again. We kind of started that pattern last time. So short leg is 4, and then in the same triangle, the long leg is x plus 6. Okay, short leg is x, over the long leg is 4. If we did big triangle to small, okay, big triangle to small triangle, it would be 4 over x is equal to x plus 6 over 4. And either way, you can see we're going to multiply 4 times 4 and x plus 6 times x. And we're doing the same thing here. Okay, let's go ahead and finish. So 4 times 4 is 16. X times x plus 6, we have to do that distribution here. So we're going to get 16 equals x squared plus 6x. Okay, we have ourselves a quadratic. So remember, whenever we see that x squared and what our goal is, right? Number one, we want to get it equal to 0. Okay, we want to be in that standard form. 2, we're going to factor. Okay, and 3, we want to set equal, or we're going to set each of the factors equal to 0 and solve. Okay, so we want to use our what's called our zero product property. We're going to put that ZPP down for us. We're going to set each factor equal to 0 and solve. Okay, so zero product property and solve. Okay, so let's do it. Step 1, get it equal to 0. Got to move that 16 over to the other side. So we're going to get 0 equals x squared plus 6x minus 16. Okay, let's see if you guys can factor this. All right, let's go ahead and pause it now. See if you can come up with your factors. All right, hopefully you remembered that we're multiplying to get negative 16. So the options are, there's 3 of them, right? We can do 1 and 16, we can do 2 and 8, or we can do 4 and 4. And the only way to get a positive 6 from these factors is to use the 2 and the 8, okay, with the 8 positive and the 2 negative. So we're going to do x minus 2 in one of the parentheses and x plus 8 in the other. So the zero product property says we set each of these equal to 0, okay, and then we solve both. So if x minus 2 is equal to 0, we would add 2 to get x equals 2. And if x plus 8 equals 0, we would subtract 8 to get x is equal to negative 8. We put that little or in the middle. And which of these answers would make sense in this question? Hopefully you realize that it can't be a negative answer. We have to use 2. And we're looking for, okay, the length of AC. So remember, if we're using 2, we have 2, and then we have 2 plus 6, or 2x plus 6, right? So AC is 2 plus 2 plus 6, and that's 10. And final answer. Okay, that's it for today. We're going to finish up with these questions tomorrow. So hopefully you guys enjoy the rest of your day. And hopefully we'll see you everyone in school tomorrow. Check your email, see what's going on the end of the day, and we'll talk to you then.